Hello and welcome to Anago Maths, International Advanced Subsidiary Stroke Advanced Level, Core Mathematics C12. Answer the questions in the spaces provided. You should show sufficient working to make your methods clear. Answers without working may not gain full credit. The total mark for this paper is 125. This is question number 1. Solve using algebra. That's part A, and then that's part B. Solve using algebra. If we notice there's x there, x there, x there. X is common, so we take x out of the bracket. So factorizing out the x, you have 6x squared plus 5x minus 6 equals to 0. So either x is equals to 0, which is one of them, or 6x squared plus 5x minus 6 is equal to 0. And when you factorize that quadratic, you will get 3x minus 2 and 2x plus 3 is equals to 0. Now, 3x minus 2 is equals to 0. Minus 2 goes to the right, it becomes plus 2. Times 3, it goes to the right, it becomes divided by 3. So x equals to 2 divided by 3. Now, 2x plus 3 is equals to 0. Plus 3 goes to the right, it becomes minus 3. Times 2 goes to the left, to the right, it becomes divided by 2. So the answer is minus 3 divided by 2. So your three answers, x equals to 0, x equals to 2 over 3, and x equals to minus 3 over 2. And you can do it with a calculator where you would put 6 for A, 5 for B, minus 6 for C, and the last term D, you put 0 because it doesn't exist, and it will give you the three answers, 1, 2, 3. Part B, hence solve for 0 less than equals to theta less than pi. 6 sine cube theta plus 5 sine squared theta minus 6 sine theta equal to 0. Giving your answers as appropriate to three significant figures. So we can replace sine theta with x. So let x be equals to sine theta. So that is the same 6x cubed plus 5x squared minus 6x equals to 0. So from before, because it says hence, from before when we solve it, we had x is 0, x is 2 over 3, or x is minus 3 over 2. So now we replace x, x is sine theta. So we say sine theta is equal to 0. So inverse sine of 0 is 0. Sine theta is equal to 2 over 3. Inverse sine of 2 over 3 is 0.730. Put your calculator in radians because it's one says you see pi there, your calculator should be in radians. Sine theta is minus 3 over 2. So inverse sine or arc sine of minus 3 over 2, it gives you an error in the calculator. So when you sketch the graph, you would have theta would be 0, 0.730 or 2.41. So you have the curve, that's where they meet there, 0.730 is that point there. And then the other one where theta is equals to 0 is there. So that's how you check your answers with the calculator. You plot the graph of y equals to sine x and y equals to 2 over 3. So y equals to sine x between 0 and pi, you would have the blue curve, and y equals to 2 over 3. You want to find where they meet. So that's one point where they meet. That gives you the 2.41, the other answer. That's the point where they intersect. And if you do y equals to sine x and y equals to minus 3 over 2, minus 3 over 2 is the one in red, and y equals to sine x, the one in blue. If you notice, they do not meet anywhere. That's why this one has no solution. And this is the view window, the settings that you would use for the x-axis and the y-axis so that you can see the diagrams clearly. And it's very important to do that. It helps you to check your work. Another way to check your work is you plot the graph of the 6 sine x cubed. That's how you put 6 cube x or 6 sine x cubed plus 5 sine x and so on in your calculator. And so that's the 6 sine x cubed plus 5 sine x squared minus 6 sine x. That's the shape of the graph there in blue. And then you can solve it because it says it's equals to 0. You can find the roots. So that's one of the answers, 0.729. And that will be another answer there, 2.41. So you got one of the answers there. That's 0.7. That's one answer. The one with 0 is there, and the one with 2.41. That's another way you can check your answer using the calculator. But make sure you do the algebra because they want you to show and do it algebraically. But this calculator is just to show you that your answers are correct. Question number 2. Find the integral of that, writing each term in simplest form. When we integrate, we use this formula for integration. Integral of x to the n, you add 1 to the power n plus 1, and you divide by the new power n plus 1, and plus integral of constant of integration c. So we want to integrate that function. We have to take the x cube to the top. So it becomes x to the minus 3. So that x cube goes to the top, the numerator, it becomes x to the minus 3. Now you've prepared the function, you can integrate it. Add 1 to 4, 4 plus 1, it gives you 5. And you divide by the 5. Add 1 to minus 3 plus 1, it gives you minus 2, and you divide by the minus 2. And this one is like x to the power 0. So when you add 1 to it, you just get x to the 1. And when you divide by 1, it stays the same, and you add the constant of integration. So 15 divided by 5, it gives you 3. 4 divided by minus 2, it gives you minus 2 over 3. And you have the x to the minus 2 and minus 4x and plus c. Or you can write it as 3x to the 5 and take this x to the minus 2 down. It becomes minus 2 over 3x squared minus 4x plus c. Those are the 4 terms of it. A sequence is defined by u1 is equals to 5 and un plus 1 is equals to kun plus 2. Find u2, u3, and then also you do part B. We start by putting n equals to 1. So u1 plus 1 gives you u2. So that will be ku1 plus 2. So we have u2 is equals to ku1 plus 2. And do we know what u1 is? u1 is 5. So we replace u1 with 5. So u2 is k times 5 plus 2. That means u2 is 5k plus 2. We always put the number in front. 5k plus 2, and that's u2. We put n is equals to 2. So 2 plus 1, it gives you 3. So ku2 plus 2. But do we know u2? Yes, u2 is the one we got up here, all of this. So we take all of that and replace it. 5k plus 2 is u2. So replace u2 5k plus 2. And we remove the bracket. K times 5k is 5k squared. K times 2 is 2k plus 2. So that's u3. Part B, given that u3 is 2, find the sum from n equals to 1 to 3 of un. So we know u3 is 5k squared plus 2k plus 2, and they've told us that's equals to 2. Now we want to solve it. You take this 2 to the left, it becomes minus 2. So 2 minus 2 is 0. So we're left with 5k squared plus 2k equals to 0. There's k there and there's k there. So factorize k out and we have 5k plus 2. So either k is equal to 0 or 5k plus 2 is equal to 0. Plus 2 goes to the right, it becomes minus 2. Times 5 goes to the right, it becomes divided by 5. So k is 0 and k is minus 2 over 5. Minus 2 over 5 is the same as minus 0.4. We want to sum from n equals to 1 to 3. So 1 u1 plus u2 plus u3, because we're going from 1 to 3. So u1 is 5, u2 is 5k plus 2, and u3 is 2, because they told us u3 is 2 from there. And we got k is minus 0.4. We substitute k is minus 0.4. So 5 plus 5 times minus 0.4 plus 2 plus 2. And that gives you 7. I couldn't figure out why the baseball kept getting larger. Then it hit me. Question number 11. F of x is equals to 13 plus 3x plus x plus 2 bracket x plus k all squared. So we're going to do part A and then part B. So part A, given that x plus 3 is a factor of f of x, show that a possible value of k is 5. If x plus 3 is a factor, we write x plus 3 equals to 0. Take plus 3 to the right-hand side, x equals to minus 3. So we're going to substitute x equals to minus 3 for x. So wherever we see x, we'll replace it with minus 3. So minus 3 there, minus 3 there, minus 3 there. And when we do that, we'll get this expression. And we want to solve it to find what k is. So we'll end up with having k is equals to 5. So you have 13 minus 9 minus 1 bracket minus 3 plus k all squared. And when you take the minus 3 plus k all squared to the right-hand side, it becomes plus bracket minus 3 plus k all squared. Get rid of the squared, becomes square root of 4. And you would end up getting k equals to 5. So that's a possible value of k. Or if you do it the other way, minus 2 is equals to minus 3 plus k. So 1 equals to k. That's another possible value of k. Part B, given that k equals to 5, write f of x as the product of two algebraic factors. Show that the equation f of x equals to 0 has only one real solution. So what we need to do now is to multiply out x plus 5 all squared, because we've put k is equals to 5. K is equals to 5. So we multiply x plus 5 times x plus 5. It gives you x squared plus 10x plus 25. And then we multiply that with x plus 2. So if you follow those lines to multiply them, you'll get this long expression. So x times x squared, it gives you x cubed. X times 10x, it gives you 10x squared. x times 25, it gives you 25x, and so on. After that, I've put them in green color. The one in green, 3x plus 25x plus 20x, that gives you 48x. And 10x squared plus 12x plus 2x squared will give you 12x squared. And you have the x cube. And then 13 plus 50 will give you 63. And you're given that x plus 3 is a factor of f of x. So you do a long division. X cubed plus 12x squared plus 48x plus 63 divided by x plus 3. So x cubed divided by x, it gives you x squared. X squared times x, it gives you x cubed. X squared times 3, it gives you 3x squared. You subtract. X cubed minus x cubed is 0. 12x squared minus 3x squared is 9x squared. 9x squared divided by x, it gives you 9x. 9x times x, it gives you minus 9x squared. 9x times 3, it gives you 27x. You subtract 9x squared minus 9x squared is 0. Bring down the 48. 48 minus 27 give you 21x. 21x divided by x is 21. 21 times x is 21x. 21 times 3 is 63. Bring down the 63. 21x minus 21x is 0. 63 minus 63 is 0. So you have x plus 3 and bracket x squared plus 9x plus 21. Show that the equation f of x equals to 0 has only one real solution. So if you try to factorize this quadratic, a is 1 in front of that. B is plus 9. C is 21. So use b squared minus 4ac. So it will be 9 squared minus 4 times a is 1 times c is 21. That gives you minus 3. And b squared, the discriminant, minus 4ac is less than 0. So b squared minus 4ac is less than 0 because you get minus 3. So there's no solution. So that means x equals to minus 3 is the only real solution. Question number 12. Figure 2 shows a sketch of the curve with equation y equals to tan x. Part A. Show that the x coordinates of points A and B satisfy this equation. And part B. And we have part C. So what we can do is y is equals to tan x. Y equals to 5 cos x. Tan x is sine x over cos x. So we have 5 cos x is equals to tan x. So we replace tan x with sine x over cos x. So tan x, we replace it with sine x over cos x. And we divide by cos x on the right. If we take it to the left, it becomes times cos x. So 5 cos x times cos x is 5 cos squared x. And that's equals to sine x. But we can replace cos squared x with 1 minus sine squared x. Because we want everything to be in sine. So we want to replace cos squared with 1 minus sine squared. So write 5 bracket 1 minus sine squared x equals to sine x. 5 times 1 is 5. 5 times minus sine squared x is minus 5 sine squared x. So we put everything to one side, to the right hand side. So n over 5 sine squared x plus sine x minus 5. So the aim was to replace cos squared x and to change tan x. Part B. Hence, find to two decimal places the x coordinates of A and the x coordinate of B. Hence means we use the answer from before. And it says solutions based entirely on graphical or numerical methods are not acceptable. So you can use your calculator to check your answer, but you need to show you're working. So we can replace sine x with x. So it's 5x squared plus x minus 5. You use your calculator to solve the quadratic, and you would get what sine x is. So I've shown you here a picture. If you put a, the number in front of x squared is 5. You put b is 1. You put c is minus 5. You get the two answers there, 1, 2, from the calculator. So we know sine x is 0.9049, that first one. So inverse sine of that 0.9049, it gives you 1.13, because we are using it in radians. So make sure your calculator is in radians. And O, sine x is equals to minus 1.104. Inverse sine of minus 1.104 is an error on your calculator, because you cannot find the sign of a negative. So if you were to put that in your calculator to draw the graph to see what it looks like, you would draw sine x, and you, for the blue curve is sine x. The straight line is that 0.9049. So you find where the meet at that point there, which is 1.13, and they also meet at this point there, which is 2.01. And the view window shows you what your minimum x is. Smallest x is 0, biggest x is 6.2, and maximum for the y, maximum value, minimum y and maximum y. And that shows you the answer, but that's graphical method. So you need to show the method in your answer by doing the algebra from before. So your two answers is 1.13 and 2.01. So the calculator method here, it shows you the answer, but you need to do this algebra to show the working out. The next part C, find the number of solutions of the equation tan x is equals to 5 cos x in the interval 0 to 21. You see, ends at 21 pi. We were doing it from 0 to 2 pi. So two solutions for every 2 pi. That means one solution A, another solution B. You see where they meet there, A and B. So for up to 2 pi, there's two answers. And 2 pi is 360 degrees. So for 21 pi, we will have 20. So for up to 2 pi is one answer. So up to 20 pi would be 2 times 10. It gives you 20 answers. But we'll still have 1 pi, which is 180 degrees. So that will be plus 2. So that gives you 22. So 2 pi times 10 gives you 20 pi. And then 20 pi plus pi will give you 21 pi. So our answer for that C would be 22. Find the number of solutions of the equations. Tan 2x equals to 5 cos 2x in the interval 0 less than x less than 20 less than equals to 20 pi. Briefly explain the reason for your answer in each case. So there's two answers, two solutions for every pi or 180 degrees. So there will be 4 solutions for every 2 pi. So the 4 times 10, which gives you 40. And these are the 4 solutions, 1, 2, 3, 4. The 4 places they meet, 1, 2, 3, 4. If you put that on the graph, it shows you. Question number 13 is got part A, part B, part C. Figure 3 shows the plan view of a design for the stage at a concert. The shape of this design is a sector AOB of a circle with center O. The radius of this sector is r meter and the angle AOB is theta radians. Given that the sector has an area 200 meters squared, show that the perimeter of the sector P meter is given by. We want to derive that perimeter. So we write expression for perimeter. Perimeter is the distance around that object. So it's R plus that part. So it's 1, 2, 3. You add them up, it gives you the perimeter. But if you notice, the perimeter expression has no theta. So we want to replace this theta. What do we replace it with? We have to use the other information. They're giving us area of the sector is 200. So that's a formula for area of a sector, half r squared theta. So we have A is 200, half times r squared times theta. So 2 goes to the left, 200 times 2 is 400, is equals to r squared theta. We divide by r squared, so theta is 400 over r squared. So we're going to replace theta with 400 over r squared in that perimeter formula. So 2r plus r plus 400 over r squared. One of the r at the top would cancel with one of them at the bottom. So you end up with P is equals to 2r plus 400 over r. Part B, using calculus, find the exact minimum possible value of P. Now we need to differentiate. Before we differentiate, we take this r to the top. So it becomes r to the minus 1. So this is the formula when you take something to the top. 1 over a to the n gives you a to the minus n. When you differentiate differential of P with respect to R, when you differentiate 2R, you get 2. You differentiate R to the minus 1, minus 1 comes in front. 400 minus 1 becomes R to the minus 2. Because it says minimum, you have to put dP over dr equal to 0 for minimum. So 2 minus 400 over r squared equals to 0. If you multiply by r squared, so it becomes 2r squared minus 400 equals to 0. So 2r squared, 400 goes to the right. 2r squared equals to 400. So r squared would be 400 over 2, which is 200. And r will be square root of 200, which is 10 root 2. Now you can substitute the value for r is 10 root 2 to find the perimeter. You substitute it in that formula, you get the perimeter to be 40 root 2. Part C. Justify by further use of calculus that the value of P you have found in part B is a minimum. So you differentiate the second time, and if it's bigger than 0, it's a minimum. So this is dP over dr the first time you differentiate it. When you differentiate the second time, is d squared P over dr squared. So you differentiate 2, you get 0. You differentiate 400 r to the minus 2. Minus 2 comes in front. So there's the minus there times the minus 2 times 400. And then minus 2 minus 1. So that gives you minus 3 there. This will become a plus. So it'll be plus 800 r to the minus 3. Now the r to the minus 3 can come to the denominator. It becomes 800 over r cubed. But your put r is 10 root 2. 10 root 2 goes to the denominator. 800 divided by 10 root 2 cubed is bigger than 0 because you get 0.2828. And because that value is bigger than 0, it means it's a minimum point. It's a minimum value of P. That's how you show it. And you can put it in your calculator to show it. If you plot it as y equals to 2x plus 2x plus 40 or 400 over x, you will get this curve that looks as that shape at the top there, like that. And then you use your calculator G solve, and look for minimum. It will give you as a minimum point there. And you can see that minimum point there, which shows that that point is, it shows that 14.14, which is that point for that arrow, is the minimum point. And that is how you put in the calculator: 2x plus 400 over x. And you put the scale from minus 50 to 50, minus 50 there, up to 50 there, and then from minus 500 up to 500 there, so that you can see it clearly.